October 24th, 2025. As you hear these words, something extraordinary is happening on the side of the sun we cannot see. The far side, the hidden hemisphere, 96 million kilometers away, yet completely invisible to every telescope on Earth. For 3 days, satellites have been registering massive plasma eruptions protruding beyond the edge of our central star, explosions so powerful they exceed the entire horizon of the sun, material hurled into space at millions of tons per second. But here's what's remarkable: we don't know what's causing these eruptions. We only see their shadows, their echoes, the peaks of something violent happening on the other side. This is a story about what lies hidden, and why what we cannot see might be more important than everything we observe. To understand what's happening today, we must go back 1 week. Sunspot region AR4246, a massive accumulation of magnetic energy on the sun's surface. During its passage across the Earth-facing disk from October 14th through 21st, this region fired at least 133 solar flares. 21 of them were M-class flares, medium strength, 109 C-class, 3 B-class. The Prairie View A&M Solar Observatory documented this region as one of the most active of the entire solar cycle 25. But then, on October 21st, AR4246 disappeared. Not because it dissolved, but because the sun's rotation carried it over the northwestern limb. Behind the sun, into the region we cannot observe. And exactly there, on October 21st at 2100 hours UTC, something exploded. The Solar and Heliospheric Observatory, SOHO, registered a massive coronal mass ejection. No solar flare had been visible on the Earth-facing side. That meant only one thing: the explosion occurred on the far side. The plasma loop was so massive it protruded over the sun's horizon, visible to us though its source remained hidden, like seeing the smoke of a fire burning behind a mountain, but not the fire itself. NOAA's ENLIL computer model calculated the trajectory of this plasma cloud. Destination Venus, arrival October 23rd. Yesterday it struck. A coronal mass ejection, a CME, is not a simple plasma jet. It's a magnetic structure, a so-called flux rope, a helical magnetic field carrying billions of tons of ionized gas. The average mass of a CME, 1.6 times 10 to the 12 kilograms. That's more than the weight of all Earth's oceans. These structures move through space at velocities between 250 and 3,000 kilometers per second. The CME from October 21st was in the mid-range, fast enough to reach Venus in approximately 48 hours. But here's where it gets interesting. On October 23rd, at 1840 UTC, DOS-19 registered another massive eruption, again from the northwestern limb, again without a visible flare on the Earth-facing side. Smaller than its predecessor, but still violent enough to exceed the solar horizon. The ENLIL model shows this CME is also Venus-oriented, arrival October 26th. Today, 2 separate CMEs within 48 hours, both from the same hidden region, both directed at Venus. And then, on October 24th, this morning, a third eruption, this time from the western limb, jets shooting into space, visible in the 334 angstrom imagery from GOES-19. The pattern is clear. Whatever is happening on the sun's far side, it's not calming down, it's escalating. The question is not whether something violent is occurring there. The question is, why can't we observe it directly? And what does this blindness mean for our ability to prepare for what's coming? September 1st, 1859. British astronomer Richard Carrington observes the sun when he witnesses the most powerful solar flare in recorded history. 18 hours later, the resulting coronal mass ejection strikes Earth. Telegraph lines catch fire. Auroras are visible as far south as Cuba. The entire global telegraph system, the only form of electrical communication at the time, fails.
The Carrington event, the benchmark for solar violence.
Today's estimates suggest a comparable event would cause trillions of dollars in damage. Power grids could collapse, satellites could be permanently damaged, GPS would fail, communication systems would break down. Full economic recovery, more than a decade. On July 23, 2012, the sun fired a CME that scientists classified as a Carrington-class event. It missed Earth by 9 days. Had it hit us, the consequences would have been catastrophic. We got lucky, pure blind luck. And here's the problem: the CME from 2012 came from the sun's far side. We only saw it once it was already on its way. No advance warning, no time to prepare. Exactly like today. The European Space Agency now requires operational teams of new satellites to simulate how they would handle such an event. The Advanced Solar Particle Events Casting System, ASPEX, was developed to predict radiation storms. But all these systems have one fundamental blind spot. They can only see what's visible on the Earth-facing side of the Sun. Half of our central star remains hidden. Always? Venus is not a second Earth. No oceans, no magnetosphere to protect it. An atmosphere of carbon dioxide and sulfuric acid at temperatures of 460 degrees Celsius. But in this moment, Venus is the most important scientific instrument we have. When a CME strikes Venus, it interacts directly with the planet's atmosphere. ESA's solar orbiter and other probes in Venus orbit can measure this interaction. The strength, the magnetic structure, the energy density. The CME from October 21st hit yesterday. The one from October 23rd hits today. 2 separate data points within 48 hours. What we learn from Venus when these CMEs arrive could tell us what's really happening on the Sun's far side. The intensity, the magnetic complexity, the potential for further eruptions. Venus becomes our early warning system, not for ourselves. These CMEs don't strike Earth, but for what might come when AR 4246 or its successors return in 2 weeks. If they return, the Sun rotates with a period of approximately 27 days at the equator. What's on the far side today will be pointed directly at us in 13 to 14 days. AR 4246 will return, or what remains of it, or what it has become. We will know early November, when the hidden side becomes visible, when shadows become reality. The question is, what has developed there in the darkness while we couldn't watch? Solar activity is higher than predicted for this point in cycle 25. Significantly higher. What we see is already extraordinary. What we don't see could be critical. Today, October 24th, 2025, 2 coronal mass ejections strike Venus. 2 plasma clouds hurled from a region we cannot directly observe. Science functions through observation, through measurement, through understanding. But what do we do with half of our star that we can never see? Half of our sun remains always hidden. What happens there, we only learn when it faces us.